Hello, in this video we're going to talk about exponent rules, specifically how exponents relate to radicals and rational exponents. So the first thing we'll look at is this relationship between a rational exponent and then how it turns into a radical. 2 to the power of 1/2 can be rewritten like this. The denominator is actually going to turn into the index of the radical. And what that means is that it's going to tell us what root we're going to take of that number. So 2 to the 1/2 can be rewritten as a 2 for the index with the 2 underneath. Now that 1 still stays here with the 2 as a power, but 2 to the power of 1 is just 2. And in math and in several places, in science, everywhere else, we never write down the 2 with the radical symbol. We always understand that, and it's well known that that is the index of 2 means the square root. What number multiplies by itself to give us 2? So if you didn't know that, now you do. That's how we leave it. It's just the square root of 2 to the power of 1/2. So likewise, -4 to the power of 3 over 2. I'm going to rewrite this as -1 times 4 to the 3 over 2. I always like moving that -1 out front so I don't have to deal with it. The next step, I'm going to bring down that -1. It's just sitting there out off to the side for now. The denominator of 2 in my exponent, that's going to become the index. So now I'm taking the square root of 4 and then raising it all to the power of 3. Cool thing about radicals and exponents is that they undo one another. So it doesn't matter which one you do first, the radical or the exponent, as we simplify. To fully simplify, I'll do -1 times the square root of 4, which is 2, and that's raised to the power of 3. 2 to the power of 3 is 8, so I get -8 for my answer. All right, so let's go from radicals back to rational expressions, see how that helps us simplify some problems. So I have 3 to the power of 4 all underneath the radical. If I don't see a number there, the index is 2. The index of a radical always becomes the denominator of the rational exponent. So I can rewrite this as 3 to the power of 4 over 2. 4 divided by 2, you can even simplify exponents. So that 4 divided by 2 becomes 2. So that's 3 to the power of 2. And if we completely simplify that, wow, look at that. This becomes 9. So from a complicated expression down to something we're really familiar with. The next one, we have the cube root of 4 squared. So we're going to simplify this as far as we can without getting too crazy here. What we'll do is we'll go back to a rational exponent and just explain what that looks like. 3 is the index, so it becomes the denominator of your exponent. So if I rewrite this as a rational exponent, it's 4 to the power of 2/3. That would be your answer as a rational exponent. I don't know of anyone that's memorizing their powers of 2 over 3, but we do have ways of evaluating that. We're just going to focus on converting from radical to rational exponent. And lastly, underneath a radical, you can multiply out numbers. So if I do 2 times 16, I get 5th root of 32. What I'd like to do is try to think if I could simplify that. And it turns out, yeah, there is a number that multiplies by itself 5 times to get 32, and it turns out to be 2. So 2 times 2 times 2 times 2 times 2 gives you 32. So that answer is. All right, so the next thing we're going to do is simplify some some radicals. Some radicals that are pretty straightforward to us and very familiar to us. When I see the square root of 16, we're going to think about what number multiplies by itself to give it 16. It has to be exactly by itself. So I know that 4 times 4 gives me 16. There's another number that does that. -4 times -4 gives me positive 16. So the answer to the square root of 16 turns out to be there's 2 solutions, a positive and -4. So I write it as plus or minus 4. Next I have the square root of -36. So the negative here, I'm going to rewrite this as -1 times root 36 and then evaluate just the square root of 36, meaning what number multiplies by itself to give us 36. And that's going to be positive 6 and positive 6 or -6 and -6. So 2 solutions here. I've got -1 times plus or minus 6. If I take the negative times a positive, it's going to be negative. Negative times a negative is still positive, so I still end up with the 2 solutions. My answer for this problem turns out to be both positive and -6. Cube root of 8. There's only one number that multiplies by itself exactly 3 times to give you positive 8, and that's going to be the number 2. If I make it negative, I get a result of -8 that I'd be taking the cube root of. So 2 times 2 times 2 is the only combination of 2's that'll give you 8. So this answer is 2. All right, finally we've got the square root of negative 4. Turns out we don't have a number that's going to multiply exactly by itself to give us negative 4. Looks like I can do 2 times negative 2 gives me negative 4, but I need to take the square root of it. These two numbers need to be exactly the same, so that's not going to work. And there's no way that that will ever work. So when we take the square root of a negative number, we get no solution. And I'm going to put in parentheses no real solution, and we'll talk more about that in a future video.